Now, this graph that you see over here is a typical graph that you would see that allows us to measure rate. So on one axis you have concentration. So in this graph you have concentration of reactants. You could have something else that gives you concentration of products. As long as on the y-axis you have concentration of something, and on the x-axis you have time. So concentration being measured against time, as you can see, concentration being measured against time, this gives you rate. So change in concentration over time, change in y over time taken, which would be change in x. So change in y over change in x, this is gradient. So from this graph you find that the rate can be determined from the gradient of the graph. So at any point, let's say you want to find the rate here, or you want to find the rate here, the rate is simply going to be the gradient of that curve at this particular point. The rate would be the gradient of that curve at any particular point at which you want to find the rate. Now, how do you find gradient at a particular point relating to your maths class? If you want to find the gradient here, what you do is you simply draw a tangent. So the rate at this point would be equal to the tangent, would be equal to the gradient of the tangent at that particular point. Now, if you look at this graph, so you can see that here we have two lines. So maybe that's for two different reactions. So the one in blue, you can see the trend in the rate. Let's redraw this so that it's visible for you. So let's see what's happening to the rate as the reaction proceeds. So let's start drawing tangents at different point on the pink line. So at this point, we're going to have a tangent here, 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 and here. So these are kind of tangents that I'm drawing. They are not accurately drawn, but you get the idea. And if you look at the tangents, you see that the tangent is flattening out. So the slope is flattening out. So it's going from steep, this is steep, and this is, we're starting to get horizontal. And again, coming back to your maths class, if you remember, a line that is horizontal is going to have gradient to be equal to 0. So if you have a line that's tending towards horizontal, means that gradient is going to decrease, which means that in this condition, because it's a concentration against time graph, the gradient is indicating the rate. So if gradient decreases, means that rate decreases. So on the pink graph, you can see that the slope is getting less steep, it's getting horizontal, so the gradient is decreasing, so the rate is decreasing. If you now compare with the blue graph, so they start off with the same gradient. So the initial rate of reaction for both reactions are the same at the initial rate, and again this is going to flatten out, right? So both of these reactions show a decrease in rate of reaction. But if you look carefully, you'll see that in the blue line, the gradient is decreasing faster. So it's getting horizontal in less time. So here, if we see, here it got horizontal at this time. Let's say T2. And if we see here, it got horizontal at T1. So in the blue line, it took less time for the graph to become horizontal. When the graph becomes horizontal, So if you have a line that's like this, horizontal line, gradient is 0 because it has no slope, rate is 0. And if rate is 0, what does that mean? It means that reaction is over. So the blue graph finishes at T1 and the pink graph finishes at T2, which means that it takes less time for this one would be graph A and this one would be graph B. So in graph A, it takes less time for the reaction to be over. The rate decreases faster in A as compared to B. So this is what is stated here. Now, if you look at the graph here, because the concentration is decreasing with time, if you would calculate the gradient, you will get negative values. But, like I said, as a convention, rate is always expressed as a positive value. So even if concentration of reactants is decreasing with time, the rate would still be expressed as a positive value, because when we're talking about rate, we don't make the difference between whether the product is increasing or the reactant is decreasing. Our aim is to see how much change is happening with time. So change is just a positive value. There is no negative change. You could say negative change if it's decreasing or positive change if it's increasing. But when we're talking about rate, we're simply looking at measuring the change in concentration happening. So in case you find that the gradient is negative, you would still express it as a positive value. Now you're going to attempt these questions A, B, C, and D. This is based on what we have done previously on rate of reaction, activation energy, and conditions for reactions to occur.